Hello class, welcome to our online lecture in Statistics and Probability. In this video, we're going to learn how to perform interval estimation of the population mean when our population standard deviation is given. Our specific learning objectives are the following. First, we need to solve for the margin of error for the interval estimate of the population mean when our sigma is known. So here we need also to learn how to identify or how to determine which equation or formula is to be used when looking for the margin of error when our population standard deviation is known. And our second learning objective is for us to find the interval estimates of the population mean when our sigma is known. So let us first have a short recap on what we have discussed in our previous videos. So first, to define interval estimate. So this is also known as the confidence interval. So it is a range of values within which the true value of parameter is believed to be found. So the true value of a parameter such as the population mean is usually unknown. So we learned last time that we can do point estimation wherein a single value can be used in order to estimate the population mean. For example, we can use the sample mean in order to estimate our population mean. But a single value is most of the time is not really equal to the true value of the population parameter. So our estimate, our point estimate is not always equal to the true value of the population parameter, but we know that this value can be found somewhere within ranges of value, somewhere within a range of values. We just don't know the actual value of the population parameters such as the population mean. So in interval estimation, instead of having one value to estimate our population parameter, we can have ranges of values in order to represent or to estimate our parameter. So for example, ranges of mean, so from values of mean up to another value of mean. So this could be an interval that contains the true value of our population mean. So in this lesson, we're going to learn how to perform interval estimation for the population mean. We use this expression in order to represent interval estimate of our population mean, where our mean is a value that is greater than our sample mean minus the margin of error, but less than our sample mean plus the margin of error. So our x bar is the sample mean, e is the margin of error, and the mu is the population mean. Another important concept is the confidence coefficient. So here we have a table of the common values of our confidence coefficients. So the confidence coefficients are the critical z values or the critical values. So the symbol for the critical values, z values, is z's of alpha divided by 2. So here we have the different confidence levels, common values of the confidence level and their corresponding z value or critical z value. So these are positive, negative values. So if you don't have this table, you can solve for the confidence coefficients using the equation, the process that we discussed in our previous videos. Also, to solve for the margin of error, we have two formula. first, we have the formula E is equal to positive, negative, critical value or confidence coefficient times the quantity, population, standard deviation divided by the square root of your sample size. So this equation is used when our population standard deviation is known. And if our population standard deviation is unknown, we use the equation margin of error is equal to positive negative t's of alpha over 2, or the critical value of our t times the quantity s divided by the square root of n, where our s here is our sample standard deviation. So this equation is used when the test statistics to be used is z-test, while this one is used, this equation is used when our test statistics is t-test. So here are the conditions on how to determine what test statistics is to be used. So this is the margin of error when using z-test. So when using z-test, our critical value is, or the symbol of our critical value is z of alpha divided by 2, and our standard deviation is the population standard deviation. So we use z-test when our standard deviation is known. So we have here condition. So dapat ang standard deviation is given. Dapat alam natin yung value ng standard deviation. And the sample size n must be a value that is greater than or equal to 30. So dapat yung sigma natin is given, and then our n must be greater than or equal to 30. So therefore our sample size should be, or our sample should be approximately normal, where our n is greater than or equal to 30. So dapat both of these conditions are satisfied. On the other hand, we can use this other equation for the margin of error when using t-test. So our margin of error is equal to positive negative the critical value of t times the quantity sample standard deviation divided by the square root of our sample size. So this is when our population standard deviation is ano. So we have here two cases wherein we can use our second equation, the margin of error for the test. So when samples, the first condition here, the first case here is when our sample size is less than 30. So when n is less than 30, automatic, we will use this equation to solve for the margin of error. Another case is that when our n is greater than or equal to 30, but our population standard deviation is unknown, then we will use this second equation in order to solve for the margin of error. So again, if n is less than 30, automatic, we will use this equation to solve for our margin of error. And another situation is if we have n that is greater than or equal to 30, but we do not know the value of the population standard deviation, then we will use this equation. So in our expression, mu is greater than x bar minus e, but less than x bar plus e. E natin doon is the margin of error. So we can expand it. If E is not given, we can expand it in order to see the equation for E. So here, this one is for the z-test. So this is solving for the interval estimate when our test statistic is z-test, and this one is solving for the interval estimate of the population when our test statistics is t-test. So this is for known standard deviation. So kapag given or we know the value of our population standard deviation, this one is if we do not know the value of our population standard deviation. So in this video, what we're going to learn is on how to solve or determine the value or the range of values when of the interval estimate of the population mean when our population standard deviation is known. So here are the steps in finding the interval estimate of the population mean with known sigma or standard deviation. So first, we have two procedures. So first is for the point estimate and for the general identification of criteria and test statistics. So step number one is this: we need to describe the population parameter, and usually what we are estimating is the value of the population mean. So second, we need to specify the confidence interval criteria. So we have here three steps. First, we need to check if our sigma is given and if the sample is approximately normal where our n or sample size is greater than or equal to 30. Second is if letter A is satisfied if this one is given and our n is greater than or equal to 30, then we will use the z statistics. Yeah. So we will use the z statistics, and then we also need to state the level of confidence of our confidence interval. So we have three commonly used. So we have the 99, we also have 95, and we also have the 90. But we can also have a value that is greater than 99 or less than, or any values from 1 to 100, from 0 to 100. Step number 3 is to collect and present the sample evidence. So letter A, we need to collect the sample information. So this is simply identifying the given. So if our sample mean is given, if our sample size is given, and then if our population standard deviation is given, then we need to identify and enumerate their equivalent values from the problem. For example, sample mean is not known, but we have raw data. For example, the value of our sample mean is not given, but we have raw data. Then we can solve for the value of our sample mean. And to solve for the value of our sample mean, we use the equation x bar is equal to the summation of our individual observation x divided by the sample size. So for step number 4, so for procedure B, this is where the proper interval estimation process occurs. So step number 4 is we need to determine the confidence coefficient or the critical value, and then step number 5, we need to find the value of the margin of error. Number 6 is we need to find the lower confidence limit and the upper confidence limit of our interval estimate. And number 6 is to conclude. So we need to describe the result. Ano ibig sabihin ng value na nakuha natin? So I have here example problems. So let us solve this problems in order to understand the process of interval estimation. So I have here 3 problems, but I will only show you how to solve for the interval estimate of problem 1, letter A, and for the rest of the examples, I would like you to use it as your practice problems, and we will discuss the answers during our face-to-face classes. So for number 1, scores on an exam are normally distributed with a population standard deviation of 5.6. A random sample of 40 scores on the exam has a mean of 32. Estimate the population mean with 80% confidence, 90% confidence, and letter C, 95% confidence. So what we would like to do is we want to know the interval of values, range of values with 80% confidence, 90 and 95% confidence that our interval estimate contains the true value of the population mean. So for letter A, step number 1, we need to describe the population parameter. So what we want to know here is to estimate, to find the interval estimate of our population mean, because population mean is usually unknown in real settings. Step number 2 is to specify the confidence interval criteria. So first, we need to check if sigma is given and if the sample is approximately normal and our n is greater than or equal to 30. So in our given, it was stated that the exam scores are normally distributed and our n is equal to 40. So therefore, this satisfies this condition. So our n is greater than 30. Also, the population standard deviation is given, which is equivalent to 5.6. So if letter A is satisfied, so meaning that the sigma is given, and then our sample size is greater than or equal to 30, then we will use Z statistic. And for C statistic, the critical value is given by this Z of alpha divided by 2. And then we need to state the level of confidence. So in the problem, we were asked to find 80% confidence interval. So the confidence level is equal to 80%, or simply 0.80 if we express it in decimal. Step number 3 is to collect and present the sample. So again, this is identifying what are the given information in the problem. So in our problem, the sample mean is given, which is equal to 32. The sample size is also given, which is equal to 40. And the sigma, or the population standard deviation, is 5.6. So if sample mean is not given, we can proceed with point estimation of our sample mean from the data. But since sample mean is already given, then we just need to state it. Step number 3, just state the given, so no need for solving the point estimate. And the next step is to determine the confidence coefficient. So here we will use the table, and what we are looking for is the confidence coefficient for 80% confidence level. So from our table, the corresponding critical value or confidence coefficient for 80% is positive negative 1.28. So take note, class, that if, for example, you do not have this table, you can solve for the Z value. So you just need to follow the steps you learned in our previous discussion. Excuse me. And of course, you need to have your table of areas under the normal curve, or the cumulative table. Next step, so after finding the confidence coefficient, we can now solve for the margin of error. So since in step 2 we identify that the test statistics to be used is the Z-test, Then to solve for the margin of error, we use this equation. So wherein this is our confidence coefficient. So this is our population standard deviation, our sample size, and this term here is our standard error. So therefore, if standard error is given, then you can just use standard error times the confidence coefficient. Or if not, yeah. So usually hindi naman standard error yung given. So sigma and then n, because we need to know whether sigma is given or not. So here we have our given. So our sample mean is 32, n is 40, sigma is 5.6, and then our critical value is positive negative 1.28. So using these values, we can now substitute our equation. So positive negative 1.28 times the quantity 5.6 divided by the square root of 40. Performing this operation, we will yield a margin of error that is equivalent to positive negative 1.13. Step number 6 is to find the lower and the upper confidence limit or boundary. So from our equation, from our expression of the, what do we call this, the interval estimate of population mean. So we have here the equation x bar minus the critical value times the quantity sigma divided by the square root of n, and then on the other side we just add the x bar, the sample mean, and the margin of error. So these values here are the margin of error, and since we already solved for the margin of error, then we can substitute. Instead of using those equations, we can use this expression to represent our interval estimate. So to solve for the lower confidence, we use the equation x bar minus e, and for the upper confidence, we add our margin of error to our sample mean. So substituting our equation x bar minus e and then x bar plus e. So we have here 32, the value of our sample mean. 32 minus 13 will give us 30.87, and then 32 plus 1.13 will give us 33.13. So the population mean, the estimate now, the interval estimate of the population mean is that the population mean is a number that is greater than 30.87 but less than 33.13. So our last step is to conclude. So we need to describe the result of our interval estimation. So to conclude, we can say that with 80% confidence that the interval between 30.87 and 33.13 contains the true population mean of the exam scores based on the sample of 40 scores. So take note that in concluding, you need to state the level of confidence, you need to state the interval of your point estimate. So these values here, these are your sample means. So in your, for example, in your what do you call this, the normal curve, if this is your population mean, then the sample mean x bar, this is 30.87, this is your 33.13. So it is a range of value So you need to state in your conclusion the level of confidence, the interval, and of course the size of your sample, and ano ba yung nire-represent nung mean na yun. So here, the population mean as well as the size of the sample represents the sample mean or the population mean represents the mean of the exam scores. So take note. So in order to determine whether the test statistics to be used is the z-test, the following conditions should be satisfied. So the first, the population standard deviation should be given. So dapat alam natin yung value ni sigma, and the population should be approximately normal where our n is greater than 30. So in this case, we are performing interval estimation of the population mean. So population mean when our sigma is known. So for the rest of the problems, I would like you to use it as your practice problems. So we have here problem 1, letter B, answer letter B and letter C, and then number 2, and then problem number 3. See you in our next video.